Find the derivative of f of x is equal to 1 divided by the square root of 2x plus 1 by the first principle. Now, the first principle, of course, we know it is f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now, if we have got f of 2, this means in the function where there is x, we're going to put what? Going to put 2. So same, if we have got f of x plus h in the function where there is x, we are going to put x plus h. So this is going to be equal to limit as h approaches 0 of, we are going to get this function, but where there is x, we'll substitute this. So that is 1 over, we have got a square root of 2, but where there is x, put x plus h, and then plus what? Plus 1. And then minus, now you just get a function itself, minus f of x, that is 1 divided by what? Square root of 2x plus 1. Remember, everything is supposed to be divided by h, so over h. And this is going to be equal to, we can merge what is on top as a single fraction. And how do you do that? Multiply this by what is down there. That is going to give us, so first with limit as h approaches 0, that will give us a square root of 2x plus 1. Multiply a negative 1 by this one which is down. That will be negative square root of what? 2x plus 2h plus 1. And then divide by, multiply the two denominators there. That is going to be square root of 2x plus 2h plus 1, and then square root of 2x plus 1. Because this is in the denominator again, we can as well just put it here in this denominator. That is the same thing. Okay, now at this point what we are going to do is, if we get to substitute directly where there is h, we put 0. That is going to be undefined because we don't want 0 in the denominator, so we are going to conjugate. So on top and down, we're going to multiply by the conjugate of the thing which is on top. So on top, what do we have? Square root of 2x plus 1. Just change the sign, it becomes plus. Even here, square root of 2x plus 2h plus 1. What you do on top, also down. That would be the square root of 2x plus 1, and then plus square root of 2x plus 2h plus 1. Really what is happening is, these are multiplying with everything here, and also these multiplying with everything there. Now we can see that this is the same thing as this. This is the same thing as this. All what is changing is here there is a plus, here there is a minus. So what we have is a difference of two squares. And when we've got a difference of two squared, a minus b, a plus b, this simply means a squared minus b squared. So that is what we are going to do. Just get the first thing, square it, and then the second thing also get to square it. So this is going to be equal to the limit as h approaches 0. So just get this thing, we square it. That is the first thing. Now if we square this, what do we get? The square root goes. So that will just be 2x plus 1. And then minus. We'll get the second thing, we square it. Now it's supposed to be in brackets because all these terms here have been affected by a negative. So if we square that term which we have there, the root is going to go. So that will be 2x plus 2h plus 1. And then divide everything now by, multiply first this with this. Now because these are the left hand side, they are multiplying, in other words they are attached, So you can see that this is the same as this. If you multiply the same thing, the root goes. So that will just be 2x plus 1. And then there is also an h here. And then now root what? 2x plus 2h plus 1. This will not be affected. Again, if we get this term multiplied by this term, we can see that this is the same as this. So those are going to just give us 2x plus 2h plus 1, because the root is going to cancel. And then we have got h, and then the other one remains, that is the 2x plus 1. Okay, like that. Now from here we can simplify. So this is going to be the limit as h approaches 0 of 2x plus 1 minus 2x minus 2h minus 1 divided by, on the denominator I can see that h is something that is common. I can factorize out h, and what is going to remain here is 2x plus 1 and then square root of 2x plus 2h plus 1, and then plus here what is going to remain is just that term, which is 2x plus 2h plus 1, then square root of 2x plus 1. Okay, like that. So of course this and this, they are going to cancel out. This and this also cancels out. This h will cancel us with this h. So on top, the only thing that is remaining is what? Negative 2. So I've got a negative 2 on top, and then divided by, we have got 2x plus 1 square root of 2x plus 2h plus 1, and then plus, we have got 2x plus 2h plus 1, and then the square root of 2x plus 1. Now at this point what we're going to do is, where there is x, where there is h, we're going to substitute now 0. So this will give us, immediately we substitute, the limit goes, had to be negative 2 divided by, we are going to put a 0 here. We're also going to put a 0 here. So we see what is going to remain in the denominator. We just have 2x plus 1, and then the square root of what? 2x plus 1, because this is going to become a 0. And then this also becomes a 0. So what will just remain there is 2x plus 1, and then the square root of 2x plus 1, like that. And from here, this is going to be equal to, this thing and this thing is the same. If you have got two radicals where what is inside is the same, just add what is what? Outside. And so this is going to be negative 2 divided by, if we add the same terms, take this as a, this is also as a plus a is what? 2a. So this will be more like we are saying 2 and then 2x plus 1, and then we have got the root of 2x plus what? 1. So this and that can divide. That will give us negative 1 divided by 2x plus 1, and then the root of 2x plus 1. Therefore that is how we can find it.